The Alps, Europe's highest mountain range, a massive natural barrier separating northern from southern Europe. The Lötschberg base tunnel cuts right through it. The need for mobility in Europe is increasing rapidly, in line with the continent's growing cohesion. More and more people and goods now pass through Switzerland. In a 1998 referendum, the Swiss electorate voted decisively to shift transalpine traffic from road to rail. This cleared the way for the first level-terrain railway route across the Alps. The overall contractor, ARGE Bahntechnik Lötschberg, the first high-speed rail link through the Alps. The Lötschberg base tunnel is a key element of the European high-speed rail network. It links Raron in the Valais with Frutigen in the Bernese Oberland. With a length of 34.6 kilometers, it is one of the longest railway tunnels built anywhere in the world. When it is completed, two single-track tunnels, 40 meters apart, will cut through the mountain. In a first phase, one tube will be completely equipped with railway technology and the other one for only about a third of its length for reasons of time and cost. The tubes are linked by transverse tunnels at intervals of 333 meters. If an incident were to occur, each tube can act as an evacuation route for the other. So the Lötschberg base tunnel satisfies the highest safety standards. This massive project required a construction period of 9 years and cost around 4.3 billion Swiss francs. As the company responsible for this impressive project, BLS Alp Transit AG was set up to implement and supervise the construction of the tunnel on schedule and within budget on behalf of the Swiss government. A total of 16 million tons of rock were excavated. Depending on the construction section, excavation took place by blasting or tunnel boring. A total of 88 kilometers of tunnel were excavated, including all auxiliary and exploration tunnels. The tunnel shell comprises the excavated cavity that is immediately reinforced and subsequently lined internally with concrete. Safety was the priority at all times during the construction work. Installation of the railway technology began in autumn 2004. High-quality, low-maintenance and durable railway systems are the preconditions for safe and reliable operation. Only 2 years were available for installing these systems. 2 years for installing the tracks, the catenaries and overhead lines, the cable systems, the high and low voltage equipment, the ventilation systems, the telecommunication systems, the safety systems, the mechanical equipment, the tunnel guidance systems, the signal boxes, and a whole lot more. And all this along a tunnel length of 51 kilometers. The schedule was tight, so installation of the railway technology started in the finished sections of tunnel even before the shell had been fully completed. This parallel mode of operation placed extreme demands on logistics and communications. The progress of work was also impaired by the limited space in the single-track tunnels. Minutely detailed planning and perfect coordination of the various activities were prime requirements for smooth running of the project. Even minor deviations from the schedule could jeopardize the completion date. At Mitholz, all the railway systems were installed on an experimental route, comprising 2 test tunnels, each about 100 meters in length. This is where the components, and as far as possible the installation methods, were tested and optimized. New data could then be obtained at an early stage to ensure smooth running of the operations in the tunnel. Equipping 17 operation and ventilation centres on schedule represented another logistical challenge. The equipment for these centres was pre-assembled in containers in a factory warehouse in Bern. Extensive operational tests of the equipment were subsequently carried out. The fully equipped containers were finally transported to their destinations and installed ready for use. This procedure reduced the installation time by about a year, so the systems could be put into operation without any delay. The first test trains ran in the completed tunnel in June 2006. They were run slowly at first, but afterwards speeds were increased to 280 km per hour, so that scheduled services could ultimately run at 250 km per hour. The safety and communications equipment was thoroughly tested in minute detail within numerous potential scenarios. Reduced commercial operation for freight trains is planned from May 2007. Scheduled operation with passenger trains will begin shortly afterwards in December 2007. The trains will then run at top speeds of 200 km per hour. 34.6 kilometers across the Alps, 3,000 meters below the peak of the Balhorn mountain. The Lötschberg base tunnel will cut traveling times from Bern to Brig by an impressive 36 minutes. The railway engineering systems for the tunnel cost a total of over 700 million Swiss francs. BLS Albtransit AG originally put 11 separate lots of railway technology out to tender for the individual sectors. Together with their bid, Implenia Bau AG, formerly Chocker Locher AG, and Rhomberg Bahntechnik AG also submitted a variant in the form of an overall offer. This proposal impressed BLS and an overall solution was negotiated. Our contractor group was awarded the order in June 2002. Planning and implementation of the construction project was entrusted to the Construction Consortium for the Lötschberg Railway Works, TUABL for short. The principal task of TUABL is to coordinate and supervise the 12 main contractors along with their 35 subcontractors. The benefits of this model: bundling of information flows, process optimization, minimization of interfaces, and the overall contractor has only a single contact partner and can be optimally supported. Central coordination simultaneously creates flexibility, allowing a rapid and appropriate response to changing framework conditions. Other suppliers of railway systems and shell contractors work in the tunnel in parallel to TUABL. During implementation of the project, this model decisively demonstrated its advantages and convinced the contract partners that they had made the right choice. The scope of the order comprised 57 kilometers of track installations, 51 without ballast, and 60 kilometers of catenaries and overhead lines, 1,400 kilometers of cables, 1,600 electrical cabinets, 3,200 fire detectors, 2,000 emergency lights, 3,000 signs, 133 video cameras, 437 telephones, and 420 manual fire extinguishers were also installed in the tunnel. And all that within extremely tight schedules under the restricted space conditions of a single-track tunnel. And temperatures under the tunnel roof rose to 35 degrees Celsius with air humidity of up to 95%. Thanks to minutely detailed planning and coordination, all the work was precisely dovetailed and implemented on schedule. Optimum quality was assured because faultless railway engineering systems are indispensable for safety at high speeds. Safety was treated comprehensively and across all sectors of this major project. Despite the ambitious schedule, safety had priority at all times during the construction procedure. Implenia Bau AG and Rhomberg Bahntechnik AG coordinated all safety-relevant aspects on behalf of the overall contractor in a special safety commission. Responsibility for and competence in these activities were assigned to the Safety Commission independently of TUABL. It reported directly to BLS Alp Transit AG and was responsible for the other suppliers of the railway technology as well as for the shell. Apart from the overall project management, TUABL was responsible for the entire construction infrastructure and logistics, which also serves the other suppliers of the railway technology. At each of the tunnel portals in Raron and Frutigen, a base was set up for handling goods as well as storing materials and parts. It also looked after the provisional track installations and acted as a control center for all transportation, workshops, offices and accommodation. The installation sites covered an area of 115,000 square meters. Up to 7 locomotives and 70 freight trucks were needed to transport material to the tunnel at peak times. As a result, only the finest transport and logistics solutions were good enough. Before the railway technology could be installed, extensive provisional structures had to be built in the tunnel. An autonomous power supply, a complex communication system, and the tunnel ventilation were required for the final installations. The preparation and operation of the construction infrastructure alone cost almost 60 million Swiss francs. The central management of the overall project also optimized its implementation. Instead of separate ventilation systems for the shell, installation and operating phases as originally planned, a single installation and operations system was used. The innovation and effective coordination by TUABL allowed time and costs to be saved. The first level terrain railway route through the Alps has been completed. The railway technology in the Lötschberg base tunnel was installed on schedule, within budget, and to a high quality, despite difficult conditions. The detailed planning, minutely implemented work routines, assurance of high quality, and not least observance of rigorous safety specifications set pioneering standards for the Lötschberg base tunnel. They will point the way for future projects. The construction consortium for the Lötschberg railway works, set up by partners Implenia Bau AG and Rhomberg Bahntechnik AG, is proud of this achievement.